So how do the orbital waves move? What are the parameters that are important? I think you already understood what a wavelength is and what a wave height is. And you know that waves break, especially if you've been to the beach. You see the waves keep coming and they break, especially when the waves are kind of strong. The beach may not have winds, but the waves can be strong. We'll see why that can happen. So there is a parameter called the wave steepness, which is basically the height divided by length, the height divided by length. Okay, so if the height gets too high compared to the wavelength, then the wave crests become tilted too far. It's literally like you tilting, and then if you tilt too far, you're going to fall over. So the wave breaks. And the other fundamental character that is imparted by the forcing is wave period. So time for one wavelength to pass a fixed point. So as I said, if you're sitting and watching a wave with respect to a post in the water, let's say, you count the time, number of seconds between one crest to the next or one trough to the next, assuming the waves are very uniform, idealized situation, but nonetheless that is the wave period. And wave frequency, of course, is inverse of the period, so it's 1 over wave period. Okay, so the diameter of the orbital motion decreases with depth, as we said. Why is that important? In an idealized situation, again, the wave base happens at 1/2 the wavelength, which means the distance between a crest and a crest, or a trough and a trough, if it is tilted over in the vertical, at half the distance the waveform basically disappears, and you don't feel any wave motion below the wave base. Okay, so that's this figure again, showing depth of the wave base to be 1/2 the wavelength below the still water level. Okay, that's good. The wave is moving in this direction. In the vertical, half the wavelength, the waveform disappears. You can imagine the circular orbit of the wave or the water parcel. As we said, the water doesn't really move, the wave form moves, so the water parcel will do a circle, and you can imagine this rubber ducky sitting here, and if the wave movement is this way, as the crest is coming behind, the ducky is going to move up and backward, and as it reaches the crest and the waveform moves forward, the duck is going to move up and forward, right? See, up and backward here, but as the waveform is moving, it's now going to move up and forward with the wave, right? And as the waveform, the crest passes, it's going to be moving down and forward. So it's still moving forward, but it's going down this back part of the wave. This crest has gone forward. Then it's at the bottom where it's moving down and now back again in this phase. So the wave energy advances, waveform moves. You can find many animations online. So if this ducky thing didn't make sense, then just go online and search for orbital wave motion. In the animation, we'll see this again. This will be very obvious. Okay, not a very big deal. I think you already have a good sense about it. Right. See you in the next podcast.